Oh, ja, ik ben het nu etwas.
We are live on YouTube now. At least this is what Zoom is telling me. And welcome back, everyone. We have our 31st or 31 version of our Everyone Can Contribute Cafe. And today we have a new guest. Chris joins us for doing something around machine learning. At least this is what the title says. And I'm looking forward to learn something new today. And yeah, that's basically from my side. I would just say, Chris, kick us off, do something magic, and enjoy the time.
We should say that we met, what, like 2 weeks ago at a meetup, and you were like, hey, you should come talk at this. So
yeah, that's me.
Yeah, yeah. He's very good at pressuring people in to do this. But thank you. Thank you for having me. Thank you for inviting me to the group. My name is Chris, as you heard. If you want to tweet at me, my username there is web_goddess on Twitter. I'm new to Europe, if you can't tell from the accent. I'm in Munich. I moved to Munich about 8 months ago from Sydney, Australia, where I lived for the last 20 years. For some reason, my husband and I decided that moving internationally in the middle of a pandemic was a great idea. And that's a story for maybe after. But I've been at AWS for 3 years. I was back in Sydney. I managed a team of solutions architects. And then when I moved to Munich, I joined the developer relations team. And over my career, I started out, I'm old, 2 decades ago as a web developer in the .com boom, building e-commerce websites that are all dust in the wind now. And then I was a business analyst and obviously a tech evangelist. And then I eventually sort of moved into being a people leader. So I only write code for fun these days. But what I have not been, my friends, is a data scientist or a machine learning expert. But it's always been a topic that's been kind of interesting to me and cool. And I went to a lot of talks over the years. I remember a few years ago in Sydney, I went to a developer conference that shall remain nameless, and went to a session called Machine Learning for Developers, and thinking, great, this is going to be exciting. I'm going to get some inspiration and get going. And I swear to God, within 5 minutes, it was nothing but calculus. It was slides of calculus. And I was like looking around at the other people in the room, and they're looking at me and we're like, this was a bait and switch. You tricked us into this room, because I hadn't, calculus is cool. I did it in uni. I hadn't done it since. So I promise you guys tonight, there will be no calculus. This is not a trick or a bait and switch. Instead, I thought we would just have some fun. I thought I would show you a very silly project that I have been working on, which does have some potential actual useful applications, and maybe inspire you to click around and try some things on your own. So this is my little agenda, but anytime you have questions, just interject and interrupt me. Happy to. I just have a couple slides about some of the cool things in AI ML that interest me. I think the things that interest me about machine learning are not the things that interest other people necessarily. So I thought I'd show you some of the stuff I think is cool. Why I think that even software developers who don't think they need to know about this should probably know something about it. A little bit on the AWS machine learning stack, but not too much, because then I'm going to go into my project, which I'm a knitter. That's what I do. I have my knitting sitting right here next to me for when I'm in boring meetings. I am working on a vest, stricken, ich stricke auf Deutsch, for meinen Mann. And I'm trying to combine knitting and machine learning to reverse engineer knitting patterns. But don't worry, you do not need to know anything about knitting for that part, I promise. Okay, so the cool stuff that I like about AI ML, there's new breakthroughs all the time. There's chatbots, there's self-driving cars, there's dancing robots and things like that. One that I think is cool, especially right now, is some of the things that are being done around coronavirus. So this was a bit, I saw in an internal talk at Amazon and just thought it was a really neat one. There's this competition that happens every couple of years, the CASP competition, which is Critical Assessment of Techniques for Protein Structure Prediction. So this was just last November. And the idea is they try and predict how a particular protein, the 3D structure from very long chains of amino acids, what it'll look like. And when you know what this protein looks like, it unlocks all of these breakthroughs, medical and scientific. And so this one here, the real molecule is in green and the predicted one is in blue. And of course, this is, it belongs to coronavirus and is implicated in immune evasion. So it's pretty neat how some of this is actually being used. I just got my shot on the weekend too, so it's particularly relevant to me. But the thing that really gets me excited is using machine learning to create art. And I actually curated a whole day at LinuxConf Australia in 2018 about art and tech. And I had a guy, for example, talk about procedurally generating landscapes from music that he DJ'd. I had a guy who every year participates in NaNoGenMo, National Novel Generating Month, where you try and write code that can generate a 50,000 word novel. There were a bunch of different talks. And so one of the techniques that artists jumped on pretty early with machine learning back in 2014 was Deep Dream. People are probably familiar with, but the idea is you have this convolutional neural network, which I've represented very simply here, that takes in an image, an input image, and you've trained it to recognize different types of objects like dog, cat, mouse, bear, wolf. And so when you feed in the picture of the cute puppy, the dog label lights up, right? Now, the Deep Dream thing kind of flips it and says, well, okay, well, what if we give it an input that we haven't trained it on, some animal that it doesn't recognize, like a jellyfish? And then so nothing lights up. But what we want to do is we want to try and actually trick the dog label into lighting up. So you start making modifications to the input image to try and get the dog neuron to fire. And over several iterations, you actually start getting recognizable dog parts like snouts and legs. And so artists figured out they could use this to create some really surreal, dreamlike imagery, which I think is nightmare fuel. Then you've got style transfer, neural style transfer in 2016. That Prisma AI app went really viral. And this is technology that allows you to sort of copy paste the style of an image separate from the underlying content. And so this was actually from a TensorFlow workshop I did back in 2017 in Australia. And so it was a photo of my husband and a horse, but I've applied different styles to it. It's pretty fun. There's apps that do that now. Another one you may have heard of is generative adversarial networks, GANs. GANs are, people are very worried about creating fake human beings that never existed. This is the internet. I think we should talk more about cats. There is an entire website called thesecatsdonotexist.com. And these are all cats that have been created using StyleGAN on Amazon Sagemaker, some of which look really realistic and others are frightening. That one in the upper right, I don't know what's going on there. You don't have to use GANs to create photorealistic output either. This is a piece a friend of mine back in Australia created, Jay Rosenbaum. Jay is an artist and researcher working with 3D modeling, AI, and extended reality tech. And so Melbourne had a really long COVID lockdown last year. You might have seen that. And so this piece is called The Isolation of Being. And so Jay did these sort of drawings of faces and bodies and then had a GAN turn them into landscapes, which I think is really beautiful. And lastly, who doesn't like getting pizza faster? This is one of the coolest actual business use cases I've seen. Domino's Pizza Enterprises Limited is like the biggest Domino's franchise holder in the world. They cover 9 countries, including both Germany, where we are, most of us are, some of us are, and Australia, where I used to be. And so Domino's was already getting like 70% of their orders online, even before the pandemic. And of course, the biggest thing that makes people happy is getting their pizza faster. The sooner you get it to them, the happier they are. So they launched this project in 2019 called Project 310, which was a goal of having a pizza ready for pickup within 3 minutes of ordering it or safely delivered within 10. And so they had a bunch of different ways they tried to do this. Obviously, they invented ways of cooking the pizza faster. They built more stores closer to where people lived, but it also involved predictive technologies. So they implemented the system with Amazon S3, with Sagemaker to build machine learning models. And basically the restaurants that have this like heads up display where at any given time, it's predicting which pizzas people in that area are going to order at any given time. So they can start making them ahead of time. And so by the time Michael calls up to order one, it's already coming out of the oven. And so one of the restaurants actually managed to get average delivery times down to just 5 minutes, which is pretty cool. So how's it relevant? which I don't think anyone's still asking because I told you about the pizza, which is relevant to all of us. But I know that there are some traditional software devs who think like, I'm not working on machine learning apps, therefore I don't really need to know about this stuff. But truly at AWS, and it's not just marketing spin, we believe that in pretty much in the fullness of time, every application is going to make use of machine learning in some way. All of the customers we're talking to are interested in this area, not just the ones you think of like fintechs. We've got startups, SaaS providers, media, nonprofits, retailers, everybody's looking at it. And we're just sort of at the beginning of this revolution. And I read just today even that like the demand for machine learning engineers is far outstripping the supply right now. So for your own career, you should probably want to know something about this stuff. There's also this idea, and I won't really go into it. This is a quote from Chris Bishop, who's a researcher in the UK. But there's this idea that in the future, we're not going to be coding, programming computers in the way we have in the past. Instead, we're going to be training them. That instead of just writing exact instructions for the computer, we're going to write software that customizes itself to different users and use cases. And so instead of building code of like precise functions where you always know what they're going to return, instead you're going to get a range of different responses and you're going to have to be able to deal with them. So just to give you an example of that, this is a little bit of Python that you can use to invoke Amazon Textract. So this is one of our services. You give it an image with text in it, like a scan or a photo, and it actually will analyze it and get the text out for you. So it's already pre-trained. You don't have to train it. You just call it like an API. But instead of getting back an answer, you get back a range of confidence levels. And you have to branch your logic based on those confidence levels. So it's sort of like exception handling, where you do one thing with success and one thing with failure. But it's not binary. You're going to have to deal with more than one outcome there. So again, I don't want to hit it too hard, but I think everybody needs to know something about machine learning. And if you want to get started with it, of course, just reach out to me. We've got resources like the Ramp Up Guide. We did our AWS Innovate conference back in February, which all the sessions are still online. If you Google AWS Innovate, we had like 50 sessions on machine learning and you can sign up and watch them. Don't want to go too hard on that. But yeah, I'm just going to talk about our machine learning stack just a little bit because we have a bunch of stuff maybe you aren't familiar with. Our goal, our mission is to put machine learning in the hands of every developer. And they mean that, trust me, because it involves building many different services that cater to many different skill levels. And there's a ton on here. I know it looks daunting, but it basically breaks down into 3 levels. We've got frameworks and infrastructure at the bottom, machine learning services in the middle, and AI at the top. And I'll just explain a little bit about what they mean, but I'm going to show off a couple of them as part of my project. So I thought it would be useful to put them in context. So at the top there, the AI services, those are the ones that you don't really, you just use them. The models are already pre-trained for you. Predictions, you just call an API really. That Textract service I mentioned is one. We've got image recognition, natural language processing, speech to text, text to speech. You see all those new things there. We launched this suite of anomaly detection tools last year under the Amazon Lookout brand. See, these, you just use them. You don't have to train them or anything like that. In the middle layer, what we call machine learning services, for the most part, that means Amazon Sagemaker. So we've got an IDE called Sagemaker Studio. It's got all the tools that you need to develop, train, debug, deploy, and monitor your machine learning models. I used it for the first iteration of my project, so we're going to go into that a fair bit. And yeah, they keep bringing out features faster than I can figure out how to use them, to be honest with you. And then at the bottom, if you are an experienced practitioner, you want to roll your own, sure, launch a deep learning AMI on whatever hardware you want and manage that infrastructure however you like. Not going to be demoing that part because, again, not an expert. Okay, my project. So as I mentioned, when I'm not messing around with computers, I am often knitting. I learned knitting when I first moved to Australia. I grew up in the States, but when I moved to Australia, I started knitting. I've been doing it off and on ever since. I usually leave it here so that if I'm in a meeting, I can surreptitiously knit a couple rows. And because people in tech know me as a knitter, I get tagged on tweets like this one. So this was back in April. Somebody tagged me on this one. It turns out this poor guy's mother turned one of his favorite pullovers into a cushion on the sofa. and he was devastated. And he wanted to know if someone could re-knit his sweater for him, his pullover, from a photo of it. And of course, in the replies, somebody's like, well, there has to be an app for that. And it's a joke, haha, but actually for an experienced knitter, this is a really common and easy thing to do. So to give you an example, this is a photo I took back in Sydney before I left. This is my colleague, Mega, in the kitchen at AWS Sydney. She's sitting there in this beautiful blue jumper, and I'd never seen that stitch before. So I took a picture because I'm a weird, nerdy knitter, and that's what I do. And so if you look at it, I can tell you just by looking at that photo that the sort of background texture, that is reverse stockinette stitch. I can tell that from the texture of it. I can tell that those sort of zigzaggy lines, those are made up of 3 knit stitches with a combination of increases on one side and decreases on the other, and that's what makes them zigzag. And some of that I get because I know the texture, but if I have a good enough image, I can actually zoom in and read it like reading handwriting, you know, like stitch by stitch. So what is this? This is reverse engineering. We do this in software all the time. This is taking something that a human being has made and studying it to deconstruct its design and its architecture. And it turns out, guess what? Knitters do this a lot too, all the time. And that's what got me to thinking, like, if I can do this in my head, if I can look at that picture, if I have a sweater, if I look at a picture of it, I can reverse engineer it. Why can't I train a neural network to do it too? So I started researching this a couple years back, and it turns out I'm not the only one who had this idea. This is a scientific white paper. I'm guessing you didn't expect to get one of those and to talk about knitting, but here it is. This was from the International Conference on Machine Learning, June 2019, just 2 years ago. This is a bunch of researchers at MIT, okay? MIT geeks. And so the goal of these researchers is to take a picture of some knitting, piece of knitting, a swatch, we'll call it, like a piece of fabric, feed it into a neural network to reverse engineer the pattern, take that and feed it into a knitting machine. So sidebar, knitting machines are a thing. You can buy ones for your house that are smaller, or, you know, clothes you buy in the shops are usually knitted on these big industrial knitting machines. They want to feed the pattern back in the knitting machine and get it to knit and get the identical swatch back out. So they basically want to build a knitting duplicator. Like, how Star Trek is that, right? So this paper's here. And one of the things in it, their real breakthrough is they realized that taking pictures of knitting actually kind of sucks for computer vision because wool is fuzzy. You know, you can't always get a really crisp photo of it. Also, knitted fabric is floppy, it's stretchy. So it's not great for doing this. So a big breakthrough they had was they augmented their training data of real photos of knitting with simulated knitting. Because those big industrial knitting machines that I mentioned, they come with very specialized domain-specific software that can actually simulate and model what knitted fabric is going to look like. So they use that to generate a bunch of samples too, and they found out that they got the best results by combining both real photos and the simulated stuff. And I promise you no calculus. This paper has a ton of calculus in it. You can read it. I didn't understand any of it. Except the results. The results were, they didn't quite crack it yet. They're getting close. They got like 80% accuracy, which is impressive, using both convolutional and GANs. So there's no app yet. There's no app that can do this, but people are working on it. So I decided that I would have a go myself. But rather than focus on reading a pattern stitch by stitch like they were trying to do, I would just treat it as an image classification problem. So similar to that thing with the puppy and the labels, I want to take an image as an input and output a class label for it. So just build a machine learning model that could do that. So I got a piece of paper, wrote out my little plan, not knowing how difficult this was going to be. I thought, well, I'll get some training data, right? I'll label it, I'll train a model, I'll deploy it, maybe build a little web front end to look nice, and then, you know, dance on the grave of the knitting industry. Like, woohoo, happy times. And so naively, I began. Everybody with me so far? Cool. All right. Yeah. Getting training data. Everybody told me, oh, I'm going to do this machine learning project. Guess what? You're going to spend 80% of your time cleaning data. And I thought, yeah, right. No, it's 100% true. Getting clean data is the hardest part, where you spend all your time. And a lot of machine learning projects have you start with easily available data sets, guess what? There's not a lot of knitting data out there. But I researched, I did find some. So the people who wrote that paper, the MIT researchers, they do make their data set available. So just to show you their methodology, they used one of those knitting machines to knit about 1,000 pattern samples in 5x5 grids. And the grid's really ingenious because what they did is they inserted steel rods into the grid to hold it flat and stretch it out. Because remember what I said about it being floppy? Took all the pictures, realized pretty quickly that was not going to scale. And that's when they moved to using the simulated samples as well. But you can get access to their photograph data set. I download it and play around with it. And you can see some at the bottom there. But they do kind of different styles of designs. I decided that was overkill. I just wanted to focus on whether I could identify 5 basic stitches. Stockinette, which is pretty much what every jumper's, that stitch pattern. Reverse stockinette, which is the inside out version of that. Garter, moss, and seed. These are just basic stitches with knits and purls. And because I'm an idiot, I decided to crowdsource my data from knitters. There's a lot of knitters out there. The Venn diagram of knitters and geeks, there is a lot of overlap in the middle. There's a lot of us. And people put pictures of their knitting online. But I didn't want to spend hours scraping and individually cleaning up images. So I wanted to automate stuff as much as I could. So I decided to set up an email pipeline. And I won't really go into this in detail, but the idea was that I knew I was going to need all my training data in an S3 bucket. So I set up an email address in Amazon SES where you could send in an email. The email would land in an S3 bucket. I had an Amazon AWS Lambda set up that when an email went into the bucket, it would trigger. It would save the attachment, check for viruses and stuff, save the attachment in another bucket, and then log the metadata in a DynamoDB table so I could keep track of who'd sent me images. So I tested this out, didn't take very long, got it set up. It would save me from having to just, I didn't want to be downloading them from Twitter or all over the place. And so once I had it working, I put out a tweet. You may have seen this. I don't know, because it kind of went viral. This was back in October 2019. I wrote a blog post. I talked about the type of images I wanted, what I was looking for. I shared the email address. I put it on social media. I also shared it on Ravelry, which is basically GitHub for knitters. If any of you are in Ravelry, you can friend me. And the good news is, this got retweeted 350 times. People started tagging their knitting friends and saying, hey, you should contribute to this. If you've ever read that blog, AI Weirdness, that Janelle Shea did, she messaged me and we had a back and forth, which was my rock star AI moment. And she pointed me to some other scientific papers. She's really cool. And the awesome thing was that images started to turn up in the bucket. Real people were helping me out with this ridiculous project. They were sending me pictures and being so generous and so kind. And I looked at them and it was all great. And then I looked at some more and I realized I was going to have a problem. So this is just some of them. So look, people get excited. They don't read too quickly. Some of them sent me patterns that I wasn't looking for, or they sent me pictures of their whole garment, which was lovely, but didn't have the resolution that I needed. Or they attached the wrong, some poor woman was like, I think I sent you Halloween candy. I was like, you did? So look, even with the best of intentions, crowdsourcing is a huge risk and you will spend just as much time cleaning it up. So it didn't actually save me any time. And I don't want to shame these folks. They were being super nice and trying to help me out. So I really do thank them. But yeah, crowdsourcing is not the magic wand that I thought it was going to be. So I got rid of all the dodgy images. I cropped the rest. And then it was time to get the images labeled. And rather than me sitting and doing this, because I had nearly 400 images, I think, I didn't want to do them by hand myself. I recruited a bunch of knitters to help me with this. And so one of the cool services in that middle layer we have with Sagemaker is called Ground Truth. It's basically like a UI where you can invite either a public or a private workforce to actually go through and label and create, your data, your training data set for machine learning. You can put your jobs out to Mechanical Turk and pay people a couple cents to do this. But I kind of figured this is a very specific domain, identifying knitting stitches. So I didn't trust it to just complete randoms. I needed actual knitting experts to do it. So I put out a call, I got my volunteer task force, I set the job up, and I will show you what ground truth looks like now. How about that? So I have here the console. Hopefully you can see that. So I'm in Sagemaker, and ground truth here on the edge, you can see labeling jobs. So I'll open one up and view labeling tool. So it sets up, user pools and stuff, and you can set up logins for people. It allows you to go in and customize. So you can see I created on the left here some custom instructions for them on what the different samples are and what they needed to do. But basically, one of my volunteer force logs in, it gives them a random image, and they click and identify it. So this one is garter stitch. So they would click that, submit, and just sit there doing it over and over again. And I set it up so that every image had to be reviewed by at least 3 people, just in case anybody accidentally clicked the wrong one. And you can see the 5 labels there I've got are the 5 things I'm looking for, plus an other, just in case I missed any ones that, when I cleaned them up that actually weren't any of the 5. And what you end up with is a labeled output. So you can see here's an image and label stockinette. This is actually crochet, so label other, So I had some stuff that is a cable stitch, so that's label other. So you end up with this manifest. It puts it into an S3 bucket, and you can then feed that in to start training your model, which is, of course, the next step. Am I going to switch back? Yes. So before I trained, though, I realized I had another problem. It's just one problem. I told you it was going to be lots of fails and errors in this. So one problem I realized I had is I told you I had 2 of the 5 stitches I was doing was garter stitch and reverse stockinette stitch. Garter stitch there on the left is what you get when you knit every row. And reverse stockinette stitch is you knit 1 row, purl 1 row, and it's one of the sides. They're really hard to tell apart in that picture. Like in real life, it's super easy because one of them's the same on both sides and one isn't. You can tell immediately in real life. And this had not occurred to me that flattened in a photograph, I have a hard time telling those 2 apart. And I'm like, oh crap, I'm not going to be able to trust any of the labels on these because I don't know which is which. And the labelers aren't going to know. So yeah, I realized that label was not necessarily going to be 100% accurate. Then I realized I had another problem. 2 of the other ones I had, seed and moss stitch. You see these 2 photos. These are very different, clearly distinguishable. Then I discovered that in British patterns, they use both words to refer to the thing on the left. Only Americans call the one on the right moss. So again, didn't know that. So again, these 2 labels, completely unreliable. So I'm sitting here going, oh God, I've spent all these hours and hours and I've got completely unreliable labels. What am I going to do? It's time to descope even further, right? We've all seen Silicon Valley. I'm like, what is the knitting equivalent of hot dog or not? It's stockinette stitch or not. Is it stockinette stitch? Is it not? That's all I'm going to care about. So then it's time to train the model finally. So this was back in 2019, as I mentioned, I was doing this project. And so I used Sagemaker. So Sagemaker is Amazon's fully managed service. It covers the whole machine learning workflow. It's fairly advanced. Like if you know what you're doing, it's massively configurable. I didn't. So I was going from a mix of blog posts and tutorials and things other people done. Rather than using Jupyter workbooks, I just did everything directly in the console. Not a machine learning expert. I ran my training jobs on a single P3 instance there, if you're curious, which has GPUs to excel. Hey, I work for Amazon. I figure if I can throw some resources at the thing, why not? So I'll go back to the console now and show you. Right, so Sagemaker. Let's look at my training jobs because I ran a lot of them. So training jobs. Let's just go ahead and show 100, why not? And I'll scroll to the bottom. So as you can see, it took me 7 or 8 to get one that actually completed because I'll create one so you can see what's required. You give it a name, you give it a role, you have to choose the algorithm. I use the image classification. I think, yeah, image classification algorithm was the one that I used, but it's got a whole bunch built in. I don't even know what a lot of those are. there's a lot of stuff you can do. You've got to pick the resource that you want to use. That's where I use that P3 to Excel. I don't know, I'm skipping everything that isn't default, basically. Then you've got to point it at your training data. So this is where I pointed it at the output manifest from my ground truth training job, the S3 bucket. And you give it both data for training and for validation. I'm sure some of you know this. The idea is that when you have your data set, you carve off 80% for training and 20% you save, and you use that to test the model at the end to see how accurate it is. So I pointed it at that. You tell it where to put the output, another S3 bucket. You can use spot training if you want to save money. I didn't bother with that, but it's a good option, and we'll talk about that later. You kick off the training job. So like I said, took me eight or so goes to get one that actually completed. And when I did, is that what I'm just going to do? I'm just going to go ahead and show you the actual output. Oh, then you've got to deploy it, of course. So once you've got a model that works, so let me get to that one that I just had, the model that complete. The first one that completed, stuck in it or not, takes 7. You can create a model from it. So if I go here to inference, I've got a couple models here in Sagemaker, just from different versions that I did, different models. Then once you have a model, you have to set up an endpoint configuration. So this is where I'm going to host the model so that I can then send, like an API call, send images to it and get the labels back. So you have to send up an endpoint configuration, and then you have to set up an endpoint. It's not too tricky, actually. The blog post I had, it's probably the easiest part of the whole thing. And then you can actually test it out. So I did all this. Going back to my thing here. So I trained it. So it was really easy to using SageMaker to deploy it. It takes a few minutes for the hosted endpoint to come up, but then you can start passing images to it. And then I went to build a nice little web front end. I mentioned that. My colleague, Gabe Hollenby, had some code. He shared me a little React app he wrote that I've got running here locally that you hook up to a SageMaker endpoint. The only tricky bit, if you want to do it yourself, is that SageMaker endpoints aren't accessible they're not exposed to the public. So you got to hook up API gateway and a Lambda function in there in the middle. And there's an AWS blog post about this, if you Google it, that will walk you through it. But it's not too hard. And once I had it done, so I fired up my app. So excited. I pointed at my endpoint. I drag in an image of stockinette stitch. And ladies and gentlemen, stockinette stitch. I was like, oh my God, first try, I cracked it. Who needs calculus? Like, I'm clearly a genius. Give me my PhD. But maybe I should test more than one image just to be sure. So then I dragged in some garter stitch. Oh, it thinks that's stockinette stitch too. That's not great. All right. Let me try another one. Okay, that's not even knitting. That's crochet. That's with a hook. That's not knitting at all. And so I've got this really sick feeling in my stomach now. One last test. That's a cat. That's not knitting at all. It thinks it's stockinette stitch. So cancel the PhD. I learned that nobody cracks it on their first try. Somebody described it to me as like making pancakes. The first one is always crap. You got to throw it out. So it's often the case with machine learning. You will not hit the jackpot on your first go. So I went digging into my logs to look at my accuracy on the model. 45%, worse than a coin flip. So back to data cleaning. This is just the cycle that you do. So I ran, like you saw, lots of different, I ran more than 15 different training jobs trying to figure out like the magic combination that would give me the best results. One tip that I got was to try and minimize the effects of image size and color. So I cropped them all to a fixed size. I made them all grayscale to get rid of the color. You know, I don't want to train it that all the red ones are stuck in it. I also rotated each image 90 degrees, which also had the awesome benefit of doubling my sample size. You know, it's a great way to get more training images into your data set is to just rotate them. Somebody also gave me a tip on clutter. So, you know, if I train my neural network all on images of knitting, then when I feed it the cat, it thinks everything in the world is knitting. So I need to teach it that there's other things other than just knitting. And that's what clutter is. So I downloaded this open data set of like airplanes and dinosaurs and accordions and chucked that in so that it learned that not everything in the world is knitting. And then I ran a hyperparameter tuning job, which makes me sound super fancy, but basically rather than trying out like thousands of combinations of these hyperparameters, which are exactly what it sounds like, tiny little things you can tweak in your training job, Sagemaker has a thing where you can just like kick off this automatic process where it will do that for you. It will try out hundreds of different combinations and keep track of the accuracy and tell you which one wins. So I did that, and I will show you the best results I managed to get back in 2019. So I have here, this is my little React app that's running here locally. It's pointed at my endpoint, and I will drag in some test images. So we'll start off with some stocking stitch always, and hopefully this is going to tell us, let me make it bigger. Come on. Yeah, it got stuck in it. How about some garter stitch? Remember, we're just doing stockinette or not here, not stockinette. Let's do some crochet, not stockinette. I'm breathing a lot easier at this point. Let's try our friend, not stockinette. So definite improvement on version 1, right? And these are all black and white. I don't have to do just black and white. So I did this talk at a conference, and I actually ran around at the conference and took pictures of people wearing sweaters. And so I actually then used some people's sweaters. So this was this guy named Ben. That was his sweater, which is not stockinette stitch. That's correct. There was Jill. Jill's is stockinette stitch. Yep, that's cool. Oznad should be stockinette stitch. Yes, stockinette stitch. The one that it gets wrong, because not perfect. The one that it gets wrong is this chick, Paulina. It thinks that that's stockinette stitch, and I can kind of see why. So stockinette stitch makes little V's. Like if you're looking just from a textural standpoint, little V's. And I don't know what stitch her jumper was, but you can tell it has those V's. So I think that's why it's picking it up as stockinette stitch. But anyway, yeah, so I'm thinking, great, this back in 2019, I'm really happy with this. So to show you my stats, with training job 15 plus hyperparameter optimization, 900 images, I got it up to almost 95%, which is pretty good considering I am a complete newbie at this and I mucked it up a whole bunch, which as you saw. So 2019, this is where I stopped and I was like, cool, it's sort of possible if you really dumb it down. And then literally a month after I went through all of this, AWS brought out Recognition Custom Labels, which does all of this 100 times easier. So Recognition is one of those services at the top of the stack. It's one of those pre-built ones. Out of the box, it allows you to identify like objects and celebrities and, tree, house, like basic stuff in images and videos. But it doesn't know custom domain things, like obviously knitting. And so they brought out this functionality called custom labels, where you can build your own specialized image analysis on top of it to look for images relevant to your use case. And so people are using this in like industrial applications and stuff. You don't need to train a new model completely from scratch. And you can get started, they claim, with just a handful of images. I didn't get good results from a handful, but you can start with theoretically 10 images. So I thought I would actually do a little bit of a bake-off and see how much easier or how it compared to Sagemaker. So I will quickly switch over now. So custom labels, right away, the user interface, way easier than Sagemaker. You've just got projects and data sets. A data set, let's just create one right now, and I will call it Wednesday night. You pointed at an image source. So I actually just pointed it at my old ground truth output. So I actually was able to pull in the exact same data that I used in Sagemaker, but you can also just point it at a bucket, or you can even just upload some images. So I'll click upload for now. And it actually opens up like a little UI here. I'll click add images, choose, and I will just, actually, let me go up a level. Just add in a bunch of, I don't even know what these are. Just add a handful of images. So you can do it manually like this. So if you've got a small set of just like very particular images for your use case, you can just do it this way. It's very easy. You do not have to have a lot of AWS or machine learning expertise. Then I can set up my labels. So I can set up a label, I can import it, but okay, so stockinit or not. And now I can actually go through and start labeling them. So I can just go in and assign stuff. You can also do draw bounding boxes. And if you click that, it actually opens up, it uses ground truth under the hood. You can tell this is the ground truth UI. So you can label your data that way. Like I said, you only have to have, I think, a minimum of 10 per label in order to actually kick off a training job. And so once you've got a data set in there, so I think the first one I did, I had 50. I did 10 per label, the bare minimum you can do. You click train model, that's it. You don't have to do all that other stuff that you do with SageMaker, and it just goes off and it does it. And it figures out for you how many instances it wants to use, which algorithms it's going to try. It works all of that out. And the output you get is you get here, you've got a training job. It tells you how long it took, and you can then actually start using the model. So that first one that I did was the 1033 one. It was that one there. So my 50 labels, 50 images, and I can actually go in and see, oh, view test results, there it is. So I can see the test, it carved off some test data. It's showing me true positive, false positives. So it gives you some statistics on it and stuff. So I ended up feeding it. So that was, I tested out with just the bare minimum 50, but then I fed it in the 900 from my original SageMaker job. Now, in order to actually use this, it's so easy. So literally, so this one here, let's say this one, I can literally just click use model and start. Don't have to create an endpoint configuration. Don't have to do an endpoint. I just click start, and it's gonna, and I tell it how many resources I want to have for doing inference. And that's mainly for cost. We'll talk about that pricing, but that's it. And then you can start, like, it's hosted, you can start using it. So to make a little front end, I found out that we have this super cool thing on the AWS GitHub, which is a sample, which is Recognition Custom Labels demo. It's got some CloudFormation stacks here. Basically just click it and it sets you up this full cool little web app with Cognito user to log in. And I can give you all these links later, Michael, we can share them, but Michi. And yeah, so it's picked up all the models I've got in Recognition Custom Labels. I've got a couple of them running, and so we can actually test them out. So this middle one is the one that corresponds to my recognition one. So I can't drag and drop with this one. It's just slightly more annoying, but stuck in it, 99%, boom. The cat is not stuck in it, 99%, boom. Interestingly, I started going through my test set and I'm saying, wow, it's giving me pretty comparable accuracy. It even gives me the same one wrong, that girl Paulina's. It thinks that's stuck in it as well, same as the SageMaker one did. And again, you can tell it's probably because those V's. I actually was so, like, I tweeted about this. This was a couple months back when I did this, because this was mind blowing to me after all the hours in the fighting with SageMaker. This I did in like an hour in the morning. It was nuts. It was so simple. And I even went and did a further version because I wanted to see if I could identify, go beyond just stockinette. I wanted to see if I could, for example, moss stitch, actually get it to identify. So I cleaned up my data, and I've actually got a version now that can identify the 5 different stitches that I put in there. So I was really, really happily surprised by custom labels. And I'll show you the stats. So same 900 images. It gives slightly different metrics, recognition does, to SageMaker. Instead of accuracy, it gives you this F1 score, which is sort of a composite thing. But I believe that equates to like 98%. It's at least as good as the SageMaker, if not better, keeping in mind that I did the SageMaker 18 months ago. So maybe if I did the SageMaker one again, I would even get a slightly higher accuracy than the 95 I did back then. So I was really, really surprised by this. I did a little slide for you just comparing it because I wanted to sort of put it in my own head, like to compare the two. There's trade-offs. I think the biggest trade-off for recognition custom labels is in terms of the pricing. The pricing's super simple. You pay $1 an hour to train and $4 an hour for inference, USD. But this is not something that you're going to turn on and leave on. It's going to work best for things where you have batch processes, where you turn it on, you processes a bunch of stuff, and then you turn it off again. That's where it's going to be most cost effective. And I've broken down the different pricing, and we can go through that. I won't spend a lot of time on that. The accuracy is comparable. And look, if you're an expert, go Sagemaker, because you're going to understand what all of those things are. You're going to be able to really finely tune it. But if you just want to do an image classification project quickly, you can have this up in a morning. I'm telling you, it's so fast. Most of the recognition custom labels training jobs, that is one caveat I should mention. You don't have a lot of control over the training jobs. You kick them off and that's it. They run, and it's $1 an hour. All the ones I did, most of the ones I did finished in under an hour, so less than $1. There was one with color images that ran for 4 hours. Because like I said, recognition figures out how many resources to use and how much training to do. You don't get to say all that. The maximum they can run is 72 hours, and then we'll kill them and not charge you for it. But so you could theoretically kick off a model that costs you $70. I've not seen, like I said, all the ones I've tested have been, and we say 90% of them finish in less than a day, but that's just an asterisk there for you. We do have a free tier for both Sagemaker and for recognition custom labels. So when you're getting started, that can make things a bit cheaper if you just want to do a little proof of concept. And you don't have to just listen to me. We've got a hero in Italy. Luca Bianchi is in Milan and wrote this really cool use case. So if you're like, yes, Chris, knitting, who cares? This is a really cool, legit use case. So this is a monitoring system for like air conditioning systems, you know, where once a month you need to check them and see how filthy they are, if they're going to make people sick. And this is a perfect example because you could spin it up, run your images through, and then turn it off again. And so Luca did a model on exactly what I did. He did it on Sagemaker. He did it with 2,300 images. He went through all the rigmarole of getting them labeled, he used PyTorch and FastAI. His model had around 92%. And then recognition custom labels comes out. He's like, all right, I'll throw my data in there and see what it spits out. And it came out with the same accuracy. He got the same results with like a fraction of the effort. He, in the blog post, calls it mind blowing. So you don't need a data scientist if this is the kind of use case you're doing. And like I said, I think this kind of thing is really good. Some of the other use cases we talk about are things like, let's say your company wants to identify its logo being used in like social media posts or uploads to a system. There was a great talk I saw in Australia from a site that sells cars, and they need to identify if people accidentally upload an image with their number plate in it, because like thieves, criminals, like print out people's license plates and use them to commit crimes. So you could, for example, have a batch job that checked all the user-generated uploads and flagged the ones that had a number plate in them, things like that. So yeah, I'm a big fan of custom labels. These are just my thank yous, all the people who helped. I had 53 knitters who sent me images. I had a team of 14 who did labeling for me. And I also had some really amazing folks at AWS, Aparna and Gabe, who helped me out with expertise. And that's pretty much it. We talked about some of the stuff I think is cool in AI ML. I hope everybody likes pizza. I hope you thought that was cool too. Why I think it's important, even if it's not your day job doing machine learning, it's gonna be. AWS has a bunch of different tools that you can use, even if you're not an expert, like I'm not. And yeah, my little project, which is not done, of course not. I will continue to do this. I want to get it to where I can feed it an arbitrary pattern and have it analyzed stitch by stitch. So I'll keep going with it. It's me and those MIT guys. We're racing on it. If you want to help, please let me know. And that's basically it. Does anybody have any questions?
So do you try the approach to simulate a pattern? So
that industrial knitting software costs like 50 grand. Like those machines, well, you get it with the machine. The machines are very expensive. I have a whole talk I did on YouTube. You can look it up because I've done a whole talk about how knitting patterns are basically a programming language. It's a domain-specific language. And so the best expression of it is in those industrial knitting patterns, because you can write a pattern in that DSL and it will simulate it. There used to be a cool project on SourceForge, like an open source one someone did, but I kind of was looking at maybe trying to revive that to see if I could simulate some samples, but it's like written in Java from like 15 years ago. So I've got no clue how to actually get that working. I've had a few people over the years reach out and say they might help, but it's an idea. And I think that would, because there's no way I can knit enough samples, and crowdsourcing is not the way to go. So I think simulation is definitely the key.
Because I think you can use Blender or something like that to simulate the textures, and I think you will get a ton of good images which can help.
Yeah, there are a whole, like another version of this talk has a lot more white papers in it because, as you say, video games are really where you start seeing a lot of the advances coming in this, because, you know, we can create very realistic avatars in games and in computer generated imagery, but knitting doesn't, you know when it looks wrong because it's flexible and it's a mesh. And so there's a lot of researchers who've been trying to create realistic looking knitted textiles in video games and in CGI. And yeah, they've done some really cool stuff with various ways of modeling that and making it move realistically and stretch and respond. So yeah, there's some really cool papers on that I can share with you.
Cool project.
I'm a massive nerd for this.
Always great to see people nerd out about the things they love. To be honest, like it's awesome. It's awesome to see that, to me personally. So yeah, I'm happy to go in and show you if you want to see anything else in the console. If I flashed by anything too quickly, like most of this stuff takes a while. You kind of got to pre-bake it because it takes a while to actually do it live. So I can't really do much of a live demo other than showing you the end results. But
of course. So the benefit of the custom labels is also that you don't have to train them what's not a knitting, right? Yeah, it's using transfer learning, which is, you take a model that's been trained for one thing, but you sort of feed it your own stuff. And so you don't have to, I didn't have to give it any of the non-knitting stuff. You're right. It had that already because of the underlying model that it was already using. Yeah, because this is something I've. Actually, no, wait. What am I saying? I'm wrong. No, I did, because I included the 900 images, and that included all my, actually, I can show you. So what am I talking about? I had the same problem a year ago with recognize something, and it was too. As you overfitted, or yeah, totally. Yeah. So here you can see. Sorry, what am I thinking? No, I did. Look, there's a wildcat. That's not stuck in a stitch. So yeah, this has the same clutter in it as everything else. So yeah, I did include that, and I can't remember where I found it, but there's a sort of standard set of copyright free, images that you can download and chuck in. So airplanes and animals. Yeah. Would be interesting to see when there's non-stockinette images were not in this custom label thing, how high the accuracy would be. Because that one I did with only 50 labels, where I did 10 per label, the accuracy is crap. Like, it's not actually very good. I think 10 is at least for this. 10 is far too short, too small. Being over 90% with 900 images is pretty good. It's pretty good. Yeah, I'm kind of curious how few I could get away with. So maybe that's a good area to experiment with, is try a subset and see at what point the accuracy starts to suffer. I think when you can simulate it, I think it's a whole breakthrough, because then you can automatically feed in all the labels and all the stuff. And I think then you can get a lot more accuracy out of the model. Because I wonder how they did it, like with the air conditioning systems, because you're not going to simulate that. They're going to have to have just manually labeled all that. But it was a key part in autonomous driving to use GTA and something like that to simulate environments because you can drive for days and weeks and months, but you don't get any image. So simulated is.
I think one of the big industrial knitting machines is German. There's a German one, and then the Japanese one is called like Shimaseki. There's two of them, but they're super expensive. And I think the MIT researchers actually asked them if they could use the software. So they're not going to give it to me.
Yeah. One question that I had is, you were talking about how that one Pauline sample that you have, which is stockinette stitch, but it's mislabeled. I mean, sure, your hypothesis is.
I don't know, and it's one of the challenges with machine learning is the explainability. I don't know why it thinks that is stockinette. I can conjecture, and that's one of the challenges, and even more so with recognition custom labels, because that is a black box. With Sagemaker, it's possible that if I was an expert and I went into the hyperparameters, I could tweak it until this. But I mean, I think to me, I can see why it would think that. There's another one it gets wrong. I guess it's the weaving one. I'm not stockinette. It gets that right. Yeah, there aren't many that it gets wrong, but the ones it does, you can tell why.
Yeah, the other thing, have you tried, or is there a possibility to take that model and use it outside of Amazon SageMaker, for example, to set it up in something like Deep Dream? As you were saying, Deep Dream exposes like some of the features that the model has learned, and so it might be interesting to experiment with what are the features that this model has learned, and maybe understand.
This is where I need to partner with someone who knows what they're doing. Luckily, my colleague here, Antje Barth, some of you may know, she's based in Düsseldorf. She's a machine learning, but she's just written a book on machine learning at AWS. So I just need to get Antje for a day or two and have her work with me on this. Because there's some really cool stuff I would like to do that is, I'm still learning. Yeah, I should buy her book. There's another, by the way, I mentioned Janelle Shane earlier, the AI weirdness lady, because she did she's a knitter too, and she did this really cool project where she fed a neural network with a whole bunch of knitting patterns as the training data, and then had it try and create knitting patterns, and then she had knitters try and knit them, and some of them look like things from an alien civilization. So she called it Skynet, which I thought was the most brilliant part of the whole project, like in the Terminator.
One more technical question I had before, when you showed the recognition front end in AWS or custom labels front end. There you had the possibility to configure an S3 bucket where you store your images. Does it necessarily has to be an AWS S3 bucket, or could anything else that is able to understand S3 protocol be used instead?
Your options are S3 bucket, upload images, or import them from ground truth. So I think it has to be an S3 bucket to use this, to be honest with you, underneath, but I can double check that.
Okay. Yeah, never mind.
But you don't have to manually upload them. You can already have them in an S3 bucket. You can have a whole separate process that puts them into the S3 bucket. I just showed you uploading from the computer because it's the easiest way for people who are not experts to do it.
If it's not too big, you can copy it from one bucket to another. So
yeah, and I think Luca on that blog post mentions that they use like command line, like S3 sync, so that they just did them that way rather than doing them through the console. I just like doing it through the console. It gives me the most things to show off to people.
Another thing I thought about was you said that AI/ML will be more important in the future for software development in general, and that everybody has to deal with the topic, as it grows in importance. So I heard about generating test data with the help of AI or ML, so like software tests. Do you know something about that, or is this possible with custom labels or with something that is provided by AWS too?
You could definitely do that. I mean, I guess it depends what kind of test data you're looking to create. If you're just looking to create textual, or whether you want to create images. But yeah, you could definitely do that. Create fake user accounts or realistic looking user buying histories or things like that, so that you've got realistic looking data to run and don't have to run it against real production data. Yeah, you could definitely use a number of services to do that, I think. I don't know if any of the AI services could do that. You probably are, well, this is literally my one demo here. So you're getting into areas I'm not as familiar with, but I can definitely look it up. I was looking today because I thought, ThoughtWorks do that radar every year of things that they're talking about. And that was where they had that bit about how they think machine learning model explainability is one of the big things that we need people who understand this so that they can explain why. Like for me, to be honest with you, I'm a little bit dangerous here because I don't know why this model does what I want it to do. So I am using this for test things. I'm not going to use this to decide if someone's going to get insurance or healthcare or not. I want someone who knows a hell of a lot more about it than I do, building the models that do that and being able to explain why they're coming up with what they're doing. So this is the starting point. That's why I've built a toy. But there are definitely some really interesting applications, and testing data is a good one, actually. That's a good one I hadn't thought of. Generating realistic test data. The other one is tools, and I know engineers get very nervous about this, and I do as well. But there's a bunch of startups right now who are working on solutions where no code, where instead of writing an SQL statement, you instead write out in real language, select the last 10 orders in this, and it will generate the code for you. So there's stuff like that we're going to be able to at least have to know how to work around.
But the thing with that is what I've always been interested in is the effect of retraining. So when you have your model and you train it and you and new images, your model can be much better or much worse. So that's also a big problem to retrain and keep the level at least. So.
And that's where you can actually, that's one of the things with Sagemaker. You can build out like a full CI/CD pipeline where you can, have versions, and you can kick off new training jobs and stuff. Recognition custom labels is very like you do it and it's there. And if I want to go back and add more images, I can, but it's a manual process. It's not very automated. But yeah, someone asked me today, and I talked about this earlier today, like, how do you know when to stop training, when it's good enough? And I'm like, I don't, you don't know. You go until you get accuracy that's good enough, like, or until you run out of money. Either way, like I did the cost for mine. I had it on there, but like ground truth, other than the ground truth labeling, leaving that out, like that model cost me less than $50 on Sagemaker, and it only cost me a couple bucks on recognition custom labels. But my hyperparameter job ran for 13 hours. So, if you're doing that over a lot of different models, that's going to rack up costs pretty quickly, especially that's where the spot instances come into it, because that can save you quite a bit of money if you're using unused compute power, when other people aren't. That can save you quite a bit. Run your machine learning jobs in the middle of the night. I see chat messages coming up. I hope there's nothing in there people are wanting to ask me.
No, I just wanted to share a project from our engineers, but I'm not.
I'll stop sharing. I'll stop sharing if you want to share.
Oh, no, you can also click on the URL. But I can share my screen as well, just for a second. Just need to find the right point. The thing is, we have, I think, 30K issues for the GitLab project itself. Let's just check how many do we have. Yeah, okay, it's a little more than that. And the thing is, like doing automated triaging is also an idea or an experiment, which Stan Hu is currently doing, like training a model and then classifying the new issues which are coming in, so that it's not a manual task every time someone needs to do it. I don't know how far this has gotten yet, but it's a really interesting effort.
Oh, that's cool.
To share it.
My husband and I were talking at lunch today because about another use case that we thought of, which is like he was talking about, you go to like Saturn or one of the electronics stores and they will have like the Apple booth or the Android booth set up. And so whenever they set those up in a retailer, someone has to check that it's done correctly. So imagine you could take a photo and use machine learning to actually flag that, yep, all good, or no, person needs to go and have a look at this. So you could perhaps check the setup of in-person, for events like evangelists, we always going and setting up the booth at conferences and things like that. So that was an idea we thought of.
Maybe the pictures when you're receiving a mail package, certainly from DHL or something, and Amazon does that as well. So you're getting a picture, but this is like a picture for you as the customer to verify. If that could be like scanned automatically and said, hey, okay, this is the terrace, this is the whatever window, this is the garden. This would also be an interesting approach to say, hey, this is actually the right place, which matches what the customer told me in the order description, for example.
The car sales in Australia, the guy from Car Sales who's an AWS here has done a number of talks about what they've done, which is really fascinating. So, you're selling your car, you go and you upload pictures. And so what they can do is they've now built up a model that can identify that, yes, you've done the front view, the side view, but you haven't done the rear view and the trunk view. And we know that people want to see those. So it can actually recommend to you images that you haven't included that would be useful. It checks for the license plates. That's where I learned about clutter. He did a talk on the license plates one where they trained it on just pictures with license plates. They didn't test it on pictures without license plates. So it would start identifying license plates regardless of whether there was none there or not. And so that's where I learned about the concept of clutter from. But they had a couple really interesting use cases in terms of or people will upload a car and they could actually verify without even seeing like the little logo on the front what type of car it was from the body of the machine learning model that they built up. Pretty neat stuff. Oh, is it able to understand the S3 protocol? Oh, I see what you mean, Sven. I'll look into that, Sven. Hit me up on Twitter or LinkedIn and I'll see if I can find the answer to that for you.
One thing you can try to make 1 pixel of your image white and train it again.
Oh gosh, yeah. I think what they ended up doing, they ended up like overlaying an orange, like the emoji of an orange or something. Like they ended up just putting emoji on the pictures rather than putting in clutter the way I did. But yeah.
But you can when you put 1 white pixel into an image and train it, your model completely garbage.
Yeah.
The dead white pixel problem is so you need to give them damaged images that they know that they're damaged.
So the next kind of iteration I've been working on with custom labels is trying to count stitches in an image, because it's one of the problems I do as a knitter. I sit here and I forget to count how many rows I've knitted. It'd be so much easier if I could just take a picture with my phone and it would tell me you've knitted 50 rows rather than have to sit there and actually count them. So I've actually started playing around because I showed you can draw bounding boxes around things in the image. So I've been testing out a little bit. I haven't got anything workable yet, but taking a picture of some knitting and then drawing, it takes forever, drawing bounding boxes around each of the stitches to try and teach it to represent this is each of these little V's is another stitch, and then to count how many of them stacked. So I think that'll probably be my next challenge.
I was thinking of combining machine learning with chaos engineering. So training the model with chaos, or like training it that the chaos is not the right thing. This would be an interesting challenge.
That's the Terminator. Did you like? We don't want to train it to try and come up with new ways to ruin us.
Yeah, okay, that's that's true. But it would still be an interesting challenge to see how the AI or ML is actually doing.
Come up with the optimal way to trash my application. Turn off the right combination of things that's unrecoverable.
Can you manipulate the image before it hits the model? Is this possible? So like making convolutions?
Yeah. I could put something on there, at the start of it. I'm just passing it straight through.
That way you can sharpen it up or make the edges more crisp.
Yeah.
That way you can get a better accuracy for the counting process. So.
That's what I think I'm gonna have to do is actually like try and get it down to just edges as much as possible. Make it grayscale, get it down to, really enhance the edges, chuck everything else. But yeah, it's hard because, unless you're lying it flat and taking it perfectly flat, it's gonna have to account for things not being perfect.
And another idea, would it make sense to, like, you have rather large swatches in your input photos, right?
Mm-hmm.
Like, would it make sense to take each of those and say quarter it and then train on those smaller things? Like,
yeah, that would be a way of getting more images, definitely. And that's why the rotating. So I had about 400 that people send in that I added, once you added in the clutter, I think I had 450. And then by rotating everything 90 degrees, I doubled it to 900. So really it was only actually around 450 images. And then you cheat it by doing the 90-degree thing. But yeah, if I wanted to, with the really big ones, and in fact, I think some of them probably are. I think people would take a picture of one sweater and just like take a few different photos, Yeah.
I mean, that leads me to the next question of what are the operations that make sense to apply to pictures that help with accuracy or with the model, and which don't. Like, if I mirror it, does it help? Or like Michael said, if I make one pixel white, does it?
That's where we would have to experiment. I mean, the grayscale, the biggest difference I noticed with grayscale or color was on the training time. When I left color in, that job ran for 4 hours. It ran 4 times as long. And it, it didn't result in any better accuracy. So get rid of color. I think color is a no-brainer. Get rid of color, unless you're trying to train it to recognize particular colors. But beyond that, yeah. Beyond that, I need to experiment. I need to actually see what makes a difference. What is also, how many stitches do I need in the image? Like, is it reducing it to just a texture, or is it actually looking at the individual like cellular units of the stitches? I don't know. I need to do one where everyone is really close up and one where maybe they're a little bit further away. Upside down. So I hope that's what you expected, Mishi. I hope this has been exciting and interesting, at least, or entertaining at a minimum. The cat always got a laugh when I did that one live. This was amazing.
And it was a really great insight into like the learning step with machine learning. This sounds odd, but how to approach this correctly, because I was like reading articles and reading the news and was like, yeah, I totally want to like find a use case for myself, and picking something which is not the average IT stuff, which makes your head explode sometimes. I think knitting is a great experience, and now I know everything around it. I won't start it, but it's interesting to see how many different patterns and how the recognition works. So I'm really grateful that you joined us today. And thanks for your time. And I think we had a little fun as well.
If there was only one lesson people could take, I think that's the one for me, is that when I have a new tech, you see the tutorials and they're always like, build a to-do list or something. I don't get excited about that. Like, I need an actual use case that I'm interested in to motivate me. If I wasn't interested in the output of this, I would have given up very early. So I think that's, if you want to learn something and be motivated to learn it, yeah, you need to find a use case you're interested in. Will you get knit GitLab socks? Well, my hourly rate's really expensive, so you have to knit your own.
Yeah, but I could convince you with sending you Austrian Drashikeksi in case.
Yeah, I think Michi should really be the one to knit them.
Hey, I'm happy to come back and run a knitting workshop if you want to do knitting. We can do that online too.
Live session.
I got a sock on the needles right here. Got a sock going.
I got everything I need to knit here, like not in my room, but I can just see my boyfriend's stuff, so.
Amazing.
Why not?
Is he on Ravelry? Get him to friend me.
I have no idea. Like, yeah. I know as much about knitting as I do about, I don't know. I know nothing about knitting except what you told me.
Well, the talk about being like a computer language is a really interesting one, because it has loops, it has for loops, while loops, it has a lot of the constructs, and in fact, you can knit elementary cellular automata, which means I can knit something that is Turing complete. So I have a whole other nerdy talk on just that aspect of it. But I actually gave a version of that talk to a group of knitters, to a group of old women at a knitting camp, where I taught them that they knew more about programming than they thought they did, because they were executing programs when they follow a knitting pattern. Do this 15 times, that's a for loop. They have a counter, they increment it. They just didn't call it that. So yeah, you know more about knitting than you think you do too. Cool. Well, it was lovely to meet you. I think I am well due a beer here. Are we still live? Did I just say that live on the internet?
Yeah, you said that live on the internet, but it's totally excusable.
I'm in München.
It's true.
Das Leben.
Just wanted to say we're in Germany, so we're allowed to have beer live.
Yeah. And no, I don't speak Bayerisch before anyone asks me. Other than Heuba, I learned Heuba pretty quick. That was the one I learned.
Yeah, we can.
But you're also allowed to drink a beer on lunch, right? Is it not so?
Yes,
the case?
There is in Bavaria. There is actually a law that mandates that companies can't forbid you to have a beer for lunch.
I need to look this up. This is news to me. I only just learned Brückentag. Brückentag is a genius term. I like that.
Bridge Day.
Oh, we got one coming up too. I'm excited about that. Another Brückentag coming up.
Yeah, always the Bavarians with all their holidays.
All the religious holidays.
Yeah.
But
I'm in Berlin. I'm like at the lowest end of the scale in Germany. So.
But if you want to have the highest vacation days, then you should go to Outsport. Outsport has the most vacation days that you can get in Germany, because Bavaria has the most in the States.
Yeah.
From the States perspective, but Outsport has one extra vacation day. So, and it's not so far from Munich, so it's a possibility to do that.
Good to know.
Well, if we're nerding about vacation days, I could just go wherever I like, because my position is 100% remote, and German labor law actually mandates that you follow the vacation days of the place you're staying in, not the place your company is. So if I, for example, visit my parents in Baden-Württemberg, and there was a holiday in Baden-Württemberg, I would have to adhere to that holiday. I wouldn't be able to work.
I didn't know this. I was wondering about that. Oh, okay.
Interesting.
Yes.
I didn't know that. So I need to go to Augsburg in the future.
Only on
a special day. Only on the special extra days at me.
No, I'm working at a company with unlimited vacation days. So
you take none.
Yeah, I'm working too much and taking none. No, I'm trying to exceed the 28 days, which was the previous one I had. And Yeah, to be honest, next week there's like the Bridge Day, or in Austria we say Window Day.
Fenstertag, yeah.
Yeah, or Zwickeltag. This
Okay.
is something I cannot translate.
Is it rude?
No, it's just
It's dialect.
Oh,
it's
Veg
just
Day, maybe.
yeah, it's hard to translate because it's an Austrian idiom, I would say. I don't know. David, help me.
Maybe like Veg Day.
Okay.
But not, yeah,
German is just a fun language with so many dialects that are languages in their own right almost.
Yes.
Definitely.
You were at that meetup with me, Michi, when they're like, "Oh, do you recognize that guy has a Frankish accent?" I was like, "No, what does he? I don't know." Schwäbisch. I'm like, what?
Yeah, I recognized that, and then it was like, "Can we do a Viennese from Vienna, the dialect?" And I was like, "Sure." I lived there for 7 years. I can totally do that. Anyhow, go ahead.
I just wanted to say I'm talking English so much in my day-to-day life, especially at my job, because like all the resources we consume daily are in English and all the talks we listen to are in English. I think I have become better at differentiating English accents, like Australian English from British, from American, or even some regional US American English accents, than some German accents, because there's just so damn many accents in Germany. Like I am 100% sure that for some people from the south of Bavaria who talk a totally different dialect than people from Austria, I couldn't tell if they're from Austria or from Bavaria. I would have no damn idea.
As if there is one Austrian dialect, right? I mean,
really?
individual valleys in the Alps in Austria have different dialects.
Oh wow!
I grew up near Lake Constance, so at the very south of Germany, and my mother is from the southwestern part of Germany, from Baden, where they talk Alemannisch, which is almost like Swiss German. So I understand Swiss German better than some people from Bavaria. That's like not a problem for me, which is always confusing to Swiss people because they don't expect Germans to understand them.
Here's another fun thing. In Austria, there are two brands of apple juice and orange juice, Obi and Kapi, and both companies produce both apple and orange juice, right? And so in one part of Austria, it's common to call orange juice Kapi and apple juice Obi, and in another part of Austria, it's exactly the other way around, right?
Then you come to Germany and you order an Obi Leitung, which is like apple juice with water.
Yeah.
This is something you cannot get in Germany because in Austria, it's like the water is for free. It's tap water. And when you try to order that in Germany, you need to pay for the water. And they don't understand it. And it needs to be like the mineral water with the
Kohlensäure.
Kohlensäure, danke. It needs to be like this Apfelschorle thing. And I'm like, yeah, but I just want Obi Leitung. Yeah, we don't have that. After I think 1 or 2 years trying it, I just said, okay, then give me something else. Give me a Johannisbeerschorle, something different.
There's another fun law that each place, like each restaurant, has to provide you with Leitungswasser, with tap water for free at all times. It's like back from the days where you couldn't just hop in your car. It's like from I think 1905 or even older that law, where it was like, yeah, I'm like walking to the next town or 2 towns over and I need something to drink, so you could just go there and they'd have to give you some tap water for free.
Yeah. So coming back to the beer topic.
Yes.
So also there's the same equivalent in Germany also for beer, because when you're ordering an Alster, it's the short term. So it's called also Alsterwasser. In the north of Germany, it's beer with orange lemonade.
Okay.
And in the southern or in the middle of Germany, it's with citrus lemonade. So it's mostly beer with Sprite, or in north you can get beer with Fanta.
Is that like a Radler? Is that like a Radler?
Yeah, it's like a Radler. Yeah.
Okay.
Yes.
I recently learned there's people who drink beer with Coca-Cola here. That's a thing. There's some name for it.
That's called diesel in southern Germany. It's called diesel because it looks like diesel fuel.
Yes. Why?
And then there's people who say that beer is not beer anymore if you put something other than just water in it. So
well, I had my first official German lesson last week. I studied German in high school in the US, and I lived in Krefeld for one summer near Düsseldorf. But I'm doing new classes again because it's lockdown. I don't get to talk to anyone but the woman at the supermarket. And my teacher was very impressed that I knew Reinheitsgebot. I'm like, come on, like,
is that like the first thing you learned?
Yeah, I was like, everybody knows Reinheitsgebot. Yeah, I was like, yeah.
I was wondering if for the different German dialects we could also create some machine learning models, right?
Well, that would be really interesting because someone put me onto this music group called Die Hundskrippeln, who I think are a Bavarian rock band. They're on YouTube. It's a slang term, Die Hundskrippeln, I think. And they have a song called Bayerischer Wald, and I understand like 10% of it. And the lyrics are in obviously Bayerisch, and Google Translate does not handle Bayerisch. So yeah, I need more machine learning models that handle regional slang. Yeah, them. They're really good. They slap, man. They're good. But I don't understand most of what they say.
That's an insulting word. Okay.
Oh, is it? Is it rude?
Yeah.
Ooh. Good to know. People sharing.
I don't know any Bavarians, so sorry.
I only opened the website and tried to translate it from German to English.
It's a German cover. It's a German cover from My Chemical Romance. It's this song. If you're.
I just wanted to wrap it up for the live stream because we're still live and talking about
beer and
machine learning.
Yeah, machine learning. That's what we're talking about.
I was just like trying to serve some time for Chris for getting a beer and then coming back. But I just wanted to say thank you again and give a shout out to Chris. And next week, we will dive into continuous profiling with Frederick from Polar Signals. This is the next week's topic, totally different to machine learning, but maybe not. I don't know. Let's see about this. And with that,
one thing I forgot to say, and because I am wearing my AWS shirt. Our summit is in 2 weeks from today. So if you don't know about it, it's our big event. It's online this year. It's free. It's on the 9th and 10th, just AWS summit, and you can register and you'll be able to watch all the sessions afterwards as well on demand. So it's worth signing up just so you get access to all of them. We've got last year, I think they had like 50 sessions. This year, we've got like 250. And we have an entire German language track as well this year that my colleague Dennis has been curating. So there's a whole 18 tracks auf Deutsch. I don't know what accent the speakers will have, but yeah.
You have 2 weeks time to learn it.
Yes. So yeah, sign up for that. It'll be cool. I'll be there.
Yeah. And we will share everything we talked about today in the blog post later on. And yep. So thanks for listening and bye on YouTube.